Hey everyone, welcome back to another video of mine, where today we're going to be solving Leetcode problem 5 titled Longest Palindromic Substring. So we're given a string S, and we simply need to return the longest palindromic substring in S. One line statement, pretty concise, pretty clear. But before we actually start going into the examples, let's just kind of talk about what a palindrome actually is. Right, so let's say I have three input strings. One is going to be 1 to 1. The other is going to be A, B, C, and the last one is going to be in a string of A, B, I. So how do we actually tell if these strings are palindromes or not? And let me actually comment this out and kind of just define what a palindrome is. So a palindrome is actually a palindrome if and only if it reads the same both backwards and forwards. In other words, also known as left to right and right to left. So using that definition, let's kind of just go ahead and evaluate the data types or palindrome types of these three input strings. So 1 to 1, let's read this from left to right first. It'd be 1 to 1, right? This is going to literally evaluate to 1 to 1. Now if we evaluate this from right to left, or basically from backwards now, this should also still read to 1 to 1. Since these two strings are actually equal, or basically this input actually reads the same both left to right, or forwards, and right to left, or backwards, it's actually going to be a palindrome. So we'll just set this equal to true. Okay, I don't know why I have caps lock on. And now, okay, never mind. Okay, so let's evaluate ABC the same way, right? ABC, right, from left to right or left, right, forwards, is literally just going to be A, B, C, right? Whereas ABC, read backwards, or basically from right to left, is going to basically read CBA. And of course, CBA is not equal to ABC. They're literally the reverse of each other. And so this is not going to be a palindrome. This is going to be evaluated to false. Now, if we apply that same logic or computations to ABA, ABA read left to right is going to be ABA. And ABA read backwards or right to left is going to also be ABA, and so hence these two are equal, and so this is actually going to be a palindrome. So that's how a palindrome is really evaluated, and that's how it really works. Basically, the reverse of that should be equal to that itself, and if it is, then it is going to be a palindrome. Okay, so in example 1, we have an input string S of BABAD. And to simply return the longest palindromic substring within S, so basically it also has to be contiguous, that's as defined by a substring, we would simply return BAB because that is the longest substring within S that actually is a palindrome, right? Of course, ABA, right here, is also a valid example or answer, but since they're literally both the same length, it really doesn't matter which one you actually output. So in example 2, we would output BB, because of course that also reads the same both backwards and forwards. BB is equal to BB, and so that would be the longest palindromic substring within CBBD, and so hence that is what we're returning. So unlike longest substring without repeating characters, so basically Leetcode 3, as we covered in the other video on this channel, we don't actually just have to return the length of the longest palindromic substring, but rather the longest palindromic substring itself. So that's also something to note. So how would we actually go about this problem, right? And this is how we would do it, right? We simply need to find the longest palindromic substring in a given string S, right? That's basically the code here. So what I'm going to do is I'm going to initialize a result, or I'll just call it final variable, and this is basically going to store the longest palindromic substring, and of course it's going to be initialized to an empty string because I haven't actually scanned through the input yet. Right, and basically the final, what it does is, it simply is initialized to an empty string, which will eventually store the longest palindromic substring found during all of the different iterations of our input string S, right? This variable is simply going to hold a result, or the longest palindromic substring that we will ultimately return after we're done with our code, right? And before I actually keep going with our code, there's actually something really important to note here. We actually have two different cases when we're actually looking for the longest palindromic substring, right? The length could either be even, or the length of it could either be odd, right? Either it could be even or it could be odd. So what we need to do is, we either need to start at, if it's odd, simply the middle index and simply expand from there to left and right while we actually have a palindrome. Otherwise, we have to start from the middle two indexes. So basically our iterators have to be set to I and I plus 1 and expand left to right while we still have a valid palindrome. Right, so that's something to actually keep in mind as well. So we have final initialized to an empty string, and we actually have to have a length that we're currently monitoring for each substring that we're looking at that's actually palindromic to monitor the longest palindromic substring. So we'll have basically a final length. I'll capitalize L just to make it a little bit easier to read. And this is also going to be set to 0 because we haven't actually scanned through the input string yet. So what this final length is actually monitoring is it basically is initialized as 0, and the variable simply tracks the length of the longest palindrome found so far, the longest palindromic substring found so far in this specific iteration of our input string S. Right, and it basically, like I said before, keeps track of the length of the longest palindromic substring, and it helps the algorithm decide if a new palindromic substring that we're currently looking at for this specific iteration, if it's longer than the one that we've recorded so far or not. So now that we've actually initialized that, now let's actually loop through our input string S. So we'll say for I in the range of the length of S, basically the indices of our input string S, this is how I talked about before, right? Basically, we're going to set L and R, basically our 2 pointers that we expand left and right from, to be I and I. And since they're both equal to the I iterator, this is basically going to be an odd, comment out. This is going to be for odd palindrome lengths, because of course we start our middle index at the same thing, meaning that we only have one middle index, or basically the longest palindromic substring is going to actually be odd. And so this is our first case, right? So basically, again, what this does is it initializes these 2 pointers, L basically left and R basically right, and they're both set to the current index I, okay? So now we actually have to have our validating while loop. So basically we have to monitor while our 2 indexes, or while our 2 pointers, while they're actually within the bounds or length of our current input string S, and while we actually have been expanding to still keep a palindrome, we have to actually expand or decrement and increment our left and right pointers respectively. So what I'm going to do is I'm going to have this while loop basically validating that each specific validating substring. So I'm going to say while L is basically greater than or equal to 0. So while it's basically still within the indices of my input string S, and it's basically still a valid index, and R is strictly less than the length of S, right? Because indexes in programming are always 0 indexed. So while that's actually true, and as we expand our substring, S at R, or S at L rather, is equal to S at R, then we can actually check if we actually have found a longer index, or a longer substring. So if R minus L plus 1, or basically the current window length that I talked about last video, if that's actually greater than the final length, or basically the longest length of a palindromic substring that we've recorded so far, up to this iteration, then what we have to do is we have to set our final basically equal to S, right? We have to set our final equal to S at L till R plus 1 exclusive, right? So basically what this does is, we're using list slicing here, or index slicing. So final is basically going to be equal to, or the string final is basically going to be equal to the S from indices L till R plus 1 exclusive, right? And basically once we've done that, we need to update our longest length that we've seen so far, or basically our final length, to basically be equal to R minus L plus 1, right? Basically the new longest length that we found so far. So now that we've done that, while this is actually true, what we want to do now is we want to basically decrement and increment our pointers. So we'll say L actually minus equals 1 and R plus equals 1. And to kind of visually depict this, let's say our input string S is BABAD, Right? Let's say both L and R are set to B. We're expanding around the center while we still have a valid palindrome. So B is going to be set right here, or sorry, L and R are both going to be set to this B, or this middle index. So while L is greater than 0, so while L is still within this bounds of this string, and while R is less than the length of the S, so basically while R is within this bounds, and S at L is equal to S at R. So basically, while we expand our current palindromic substring, while we still have a valid palindrome, we're going to keep expanding while our 2 pointers are still within the range of the length, or basically in bounds of our input string S. So right now, both L and R are set to B. So since S at L and S at R are both equal to A is equal to A, and they're both still within the in-bounds of our input string S. So now we'll set L minus equal 1, so basically L equals S set L minus 1, or basically A, and R is going to be equal to A. So we still have a palindromic substring that's still valid. Now we have to basically decrement and increment our pointers by 1 again. So we'll go L minus equals 1, and we'll go R plus equals 1, but note that we actually don't have a valid palindrome anymore. B is not equal to D. Although our pointers are still within the range of our length of input string S, S at L is no longer equal to S at R. B is no longer equal to D, and so we'd stop expanding, we'd cancel this expanding, and we simply store our ABA, or basically our longest palindromic substring that we've recorded for this specific iteration of our S input string. Now, ABA is also still a valid answer, right? In this case, we outputted BAB. It really doesn't matter because if L and R were set to A here, we could still decrement and increment our pointers to be BAB, assuming L and R are A, right? Let's say L and R is equal to A. Then if S and at L and S at R are still equal to each other, we can set L to be B and R to be B, which obviously are still equal to each other. But of course, we can't go from there because L would be out of bounds, or basically less than 0, and so we can't actually keep incrementing or decrementing our L pointer, and so we'd have to stop right there. Right, so that's how basically this is visually depicted. Now that we've actually done that, now we've basically finished the code and all the validation for odd length palindromes. But we still have to move on to even length palindromes, right? We still haven't covered that section yet. So after checking for all the different odd length palindromes, what we're going to do is we're going to set L and R, we're going to reset them to I and I plus 1, right? So basically, this initializes L and the Rth pointers to be checking for even length palindromes, right? So this basically handles cases where palindromes have an even length, basically like ABBA, where the center is between 2 characters. We have 2 middle indexes, right? For example, in this even length palindrome right here for BB, L would be set to B, and R would be set to this B, basically I plus 1, right? So while, again, same functionality, while S at L is still equal to S at R, we'd basically expand around the center. So then basically D would be set to R and C would be set to L. But in this case, S at L is not equal to S at D, right? Because of course C is not equal to D, and so we'd cancel that expandation, and we'd basically set B to be our longest palindromic substring that we've expanded for so far, right? With L being I and R being I plus 1. This is basically the even length palindromes. And now that we've actually initialized these 2 pointers to basically be the I and I plus 1 iterators, we simply can literally just copy this code because it's the same validation for both even and odd length palindromes. It really doesn't matter. And now, once I've finished that, I'm basically done handling all the different cases. And so what I can do is, okay, looks like I actually forgot to copy this code. As the L minus equals 1, I'll keep expanding around the center. I'll actually have a valid palindrome that's actually in bounds of my input string S, right? Once I've done that, I've covered all the different edge cases for if I have even or odd length palindromes, and at the end of the day, I can simply return right here my final substring that I've actually basically updated. So I'll say return final. Right, so unless I made any syntax errors here, this should be completely fine, and it should be accepted. And as you can see, it is just about as efficient you can get. Memory-wise, this is going to be O of n squared, right, where n is basically the length of the string. Sorry, not memory-wise, but runtime complexity-wise, it's going to be O of n squared, because of course we have a while loop embedded within a for loop for validation of our current window. Right, so kind of just to basically get an overall explanation of this code, We're going to basically have two different edge cases, odd-length palindromes and even-length palindromes. So basically for odd-length palindromes, for each character I, the code checks if there's a palindrome centered around that character. And for every even-length palindrome, it checks if there's a palindrome between the character at position I and the character at position I+1 and expands around those two middle index centers. And for both cases, of course, it uses two pointers L and R that actually expand outward to check if the characters on both sides of the palindromic substring are actually the same. Basically, the condition for being a palindrome, as we talked about at the beginning of this video. If a longer palindrome is found during this process, the code basically updates the result res, or basically final in this case, and the length of the longest palindrome, final length. Finally, what this code does is the function basically returns the longest palindromic substring that is actually found within this code, right? And like I said before, it has an overall time complexity of O of n squared because we actually have two loops embedded within each other. And of course, n is going to be the length of the string because for each character, it checks all possible palindromes centered around that very character. So, if you guys enjoyed this video and learned something new, please consider liking this video and subscribing to my channel. It really does mean a lot, and it really does motivate me to keep going and keep posting more videos. And like I said, without further ado, I hope you guys learned something new, and I will see you guys in the next video. Bye-bye.